Hello and welcome to Learning Arduino for Beginners. I am Jay, and today we're going to take a look at ultrasonic sensors. Now for this tutorial we're going to look at how to make an alarm, a proximity alarm, and it'll use the ultrasonic sensor to detect when something comes within a defined range. It will set off an audio alarm. Now, as you can see, I have an enclosure built here. I actually built this, and I'm going to be doing another video covering the enclosure itself. In this video, we're just going to take a look at how the circuit's put together in the Arduino sketch. But what this is for is my cats behave great, except the minute you go outside and close the door, they're on the kitchen counter, kitchen table. So I am building, this is the first one, this is my prototype. I got it working perfect. I'm going to be building a couple more of these, but it's extremely loud, and when the cat jumps up on the counter and it comes within proximity of this, the alarm goes off. And I actually put this on my kitchen counter, walked out the door over to the window and watched. And not even 2 minutes later, the cat jumped on the counter. The alarm went off, and she freaked out and took off running. One or two more times she jumped up there. I've been using this for a few days now, and she has quit going on the counter. I will probably still leave it up there for a while because, well, cats are curious, and they'll be like, well, I wonder if that thing that scares me is still there. So, all right, well, let's just get into how to build this. Like I said, if you're interested in building the keep the cat off your counter project here, the enclosure and stuff, look in the description below. I will be doing a video in the next couple days on how to do that. But like I said, in this video, we're going to take a look at the circuit and the proximity alarm. And then when we get to the Arduino IDE, I'll show you, I mean, you can use the input from this to output, a distance to an LCD screen. There's lots of uses. What we're going to do is we're just going to go over some basics with it. And there's lots of other videos. I mean, if you want to hook this up, use it with an LCD screen, I do believe I have an old video from a few years ago. I did that, but there's plenty of them out there. So, all right, I'm going to open this up. Actually, you know what? Before we do anything, why don't I demonstrate it working? Now, I have this set right now at about 6 inches or closer. It will go off, and I forget, when we get to the sketch, we'll look, but this will go, quite a few feet away from it. It'll detect, and it's adjustable. And when we get to when I open it up, I'll show you there's a potentiometer in here. All right, which should be good to go. Yeah, it's a little close there. That's probably what's setting it off, but I'm right about at the 6 inches, and maybe a little more. That's why it's a little intermittent. Now, these aren't really very precise. It is set for about 6 inches, but it's about 8 or 10. It'll still go off. These are not super precise. I'm sure if you bought a more expensive one, this is a cheaper, inexpensive one from, I believe it was China or whatever. If you bought a more expensive one, it would probably be a little more accurate, but this one here was like $1, shipping included and stuff. I mean, for what I'm using it for, it works fine. I know you can get some better quality made ones that cost a little more, and they're probably a little more accurate. As you can see, I got my hand right now about 1.5 feet just off the camera, and it's just trying to set it off. And it's set at 6 inches. I also hear it's extremely loud. I'm going to unplug this. We're also amplifying the heck out of this because your regular tones from your Arduino aren't that loud. So, well, let's just open this up now and get into it. I'm going to go ahead and just disconnect the speaker to get it out of the way so we can see in here. But that's all we have, and I'm going to go ahead and zoom the camera in a little bit. There we go. You should be able to see now. Let me find my pointer. All right, well, what we have, of course, is the ultrasonic sensor. And I'm trying to remember, what is that? Okay, there's the model number. It's an HC-SR04 is what we're using. And it's an inexpensive one that I found on eBay from, I think it was from China, something like that. We got our potentiometer here. Now, I am going to be drilling a hole to run this in the side for adjusting it, because what this allows us to do is adjust the distance. I have it set at the minimum, but if you want it to go off at a distance of further away, that's what this is for. When we get to the sketch, I'll go over it more and hopefully it'll make better sense. But this is to set your maximum, well, your minimum distance for it to go off. You know, how close the item, or the, well, in my case, how close the cat has to get to it before the alarm goes off. Because if you're putting this on a counter, you might have some stuff sitting there, you know, 2 feet away, and you don't want this going off because your stuff's right there. So you use this to trim it back. And I am going to be drilling a hole, putting it in. At the time I was putting this together, these are the potentiometers I had on hand. I'm going to be getting some with longer stem and drill a hole, and that will eventually go in there. But for now, I just have this on the inside. Then what we have here, well, next we'll go over, I got right here, I got a TIP 120. It's a Darlington Npn Transistor. And that's what we're using to super amplify the tones. I am running 9 volts into this, and that's to the Arduino voltage in. And then it has a voltage regulator built in. But I'm also running the speaker, the positive on the speaker to this is running off the 9 volts. I didn't want to try pushing 12 volts. This speaker that I have on here might handle that. I just didn't want to blow it. And with the 9 volts, it is plenty loud, and I have a few of these. But the thing is, I didn't want to blow them out because I got just enough for how many of these I want to build to keep the cats off the counter. So if you have, excuse me, some extra speakers to play with, you could you could try running 12 volts, but you might not even want to amplify it. And you, oh, sorry about that. I got something in my throat. You might want to skip putting the transistor in there, the Darlington transistor, or you might just want to put a regular, you know, like a 2N2222 in there and run the 5 volts to it, because the tone output, you're not getting the full 5 off the Arduino. So if you run 5 volts through the NPN, you will get louder tones. The NPN, I do believe the 2N222 will still handle. Oh, I'm going to have to look at my data sheet. I can't remember offhand. I think the 2N2222s can handle 9 volts without a problem. I'm trying to remember the cutoff. Well, that's something for you to check out. Well, of course, then we have our Arduino in here, and I'm using a Nano. The Nano works good in here with the little half breadboard. Everything fits inside this little project enclosure. And this is just PVC pipe. And like I said, if you're interested on building this enclosure, I will be doing another video on how to do that, and you'll find a link below. Or if you're just interested in, you know, making your own just generalized PVC enclosures. Everything this is made out of came from the local hardware store, and this project enclosure was like less than $3. And I'll actually have I have a video already done on just the general project enclosures out of the PVC, and I will have a link to that in the description below as well. Other than that, we don't really have anything else. I have a plug right here to plug my wall wart plug in, and I'm running 9 volt. I think, I can't remember if it's just just barely out of reach. I think it's a 500 milliamp. I think 9 volt. It might be a little less. This doesn't draw a whole lot. But I'm recommending 9 volt through the, and remember to put it to the VN, not the 5 volt pin on your Arduino, because the 5 volt, that's the output, or if you're putting 5 volt into it. Otherwise, if you're putting a higher voltage in, run it to the VN pin, and that's this one right here on the end. Now for the schematic on how to put this together, look in the description below. I will have a schematic on the website, and you'll find a link to that, the website, in the description below. Plus you'll find a parts list and some places where you can get them if you don't like eBay. I try to stay off eBay, but well, once in a while you still got to get it there because that's where it is if you need it right now. But I'll have some links on the website to get this stuff on other places as well. All right. I think what we'll do now is we will go over to the computer and we will look at the sketch on how this is programmed, and the sketch as well. Look in the description below. You'll find that on the website. So let me get the computer fired up. I'll bring up my screen recording software, and I'll catch you there in just a moment, and we'll go over the sketch that makes this whole thing work. So, all right, I will catch you there in just a second. All right, I got the Arduino IDE brought up here, so let's just get right into it. All right, the first thing that we have here is we're defining the pins that the trigger pin and the echo pin from the ultrasonic sensor are on. And when you look at your sensor on the board, these are marked trig and echo. Now we're using pin 9 and 10. You can use other pins. Just remember, if you choose to use a different pin, change this. The long duration, don't change that. Leave that alone. Leave this integer alone. Now this here, this int for the val, that is for our alarm. If you were using this, like you're going to display the value on LCD, or you wanted to use your serial monitor on the computer, you could get rid of this. But we get down here in just a moment to the rest of the sketch. I think you'll understand. All right, now for the void setup, we have here the serial.begin, and we're setting this at 9600. Now this is for testing, or if you are going to be using this to display the stuff on your computer. If once you build this device, you could remove this line. There's a couple other testing lines we'll get to that could be removed, but it doesn't really affect anything. I just leave it in. That way I can plug this into the computer if I'm having problems and diagnose it without having to load a different sketch onto it. All right, these two pin modes for the trigger pin and the echo pin, leave them alone. Don't change that at all, or it will not work right. All right, then what we have here, all right, first what we're doing is we're reading our potentiometer, and that is on A1, analog A1. I just picked that and used it. I mean, I could have used A0, A5. I just picked A1. You can use any pin you want. Just if you change it, change that number right there. Next, this digital write and delay, this little section of code right here. Actually, all the way down to here. Don't change any of this. The only thing you might want to do is right here. You see I have this commented out. If you want to have it in metric, just take and uncomment that and then comment this out. And this will put you in metric. Otherwise, if you want US for inches, comment that out and make sure that one is not. So as you can see, it says behind it here, we have a comment, centimeters, metric, basically inches, that's US standard. All right, then what we're doing is we're serial printing the distance, and once again, that's for testing, or, I mean, there's lots of uses for this. I'm just going over the basics on the sketch I set up for the alarm. Just remember, you can change stuff. All right, now for the valve, what we're doing down here, and I could have probably taken care of this up here. It just, that's happened to be the order I stuck it. But we're just mapping that. And we're mapping, well, for your input, it's going to be 0 to 1023. And I want to set that for between 6 inches and 3 feet. So that's 36 inches, 3 feet. Now you can go further. For my applications, 3 feet's more than enough. You could go 48, go 4 feet. This sensor, the cheap one, I found 6 feet is about reliable to use with a little bit of instability. 3 feet, it's pretty darn good. If there's a big void behind it with nothing at all, it might go off once in a while. So what you want to do is, if there's a big void behind it, I mean, we're talking like 10 feet, 20 feet, there's nothing out there, you might want to set something up so it does get a return that's letting it know, yeah, there's something there, but it's over, you know, the 36 inches or 48, wherever you have it set. All right. I hope that makes sense. I really do. Then once we're just doing another serial print, we're doing the valve, and once again, this was for testing as I was putting this together, and I left it in there. That way, you know, to diagnose any problems you're having, you just plug this right into your computer, bring up the serial monitor, bam, and you can see the readings. Then what we have is when the distance, if it is less than or equal to the reading getting from the potentiometer that we mapped up here, it is setting off the alarm. I just chose pin 3. You can choose other pins. I do believe it has to be a PWM pin, pulse width modulation pin. And then you just set your tone in hertz, and then how long you want it to go. And I had the 2-tone alarm. And remember to put a delay afterwards for how long you want it to play, because when the tone goes, it automatically goes down here to the next one. It keeps going. You have to put a delay in equal to the amount or more if you want some silence between the 2 tones. And once again, hope that makes sense. And then put your other tone. Otherwise, you could just have 1 tone, or you could have an LED flash. You could have this hooked up to a Bluetooth module and have it send something to your phone, tell you it's going off. If you're using this like a burglar alarm, or you could have it set up with your Wi-Fi. I mean, there's tons and tons of uses. I just wanted to go over. This is a fairly basic one to go through for my Learning Arduino for Beginners series. And it is very useful because like I said, I built this. This is a practical project. I am using it to keep my cats off the counters because I really don't want them, going from the litter box and jumping on the counters, even though they lick their feet all the time. I mean, they didn't lick their feet clean 10 seconds before they jumped on the counter. So now I have something that is keeping them off of there and actually working pretty good. This right here actually is just something I forgot to remove from when I was designing and experimenting with this. Sorry about that, I forgot. That's nothing you need. It was just to do a delay. Actually, you probably could uncomment it if you were, and leave it in there if you were trying to diagnose a problem, and it'll do the serial print here, the distance, then the val, and then what I was doing is just doing a delay. It was doing a ½ second delay, so it wasn't just scrolling down the screen at warp 10. So I guess it could leave it in there. Just, if you're doing diagnostics, uncomment it. Otherwise, these, you could comment them out as well, but it doesn't really affect how the project works. Just remember, if you leave this delay in there, it will affect it. It will not work the way you're probably going to want it. So, all right. I think we've gone on long enough on this video. I hope all this makes sense. I hope it did. Once again, look in the description below. You'll find links to the website where you can get the Arduino sketch. And you can get the schematic for how to set the circuit up. You'll find a parts list. Also in the description below, you'll find a link to, once I get the video up, how to make this particular enclosure. Plus, you'll also find a link to how to just make general enclosures out of the PVC pipe. And with that, I guess we'll just say, hey, I hope you found this information useful. You did. Please give me a thumbs up. Appreciate it big time. I hope you have a great day. And remember, have fun building.